Hello, my beautiful listeners. Welcome again to class. It is your favorite channel, Jeff Nano Mathematics class, and today we have a topic on the board: binary operations that we are going to be talking about. All right. If this is your first time joining us, you're welcome to our channel. Please don't forget to subscribe and also help us share our videos so that other listeners of mathematics will actually learn from this particular topic. So in today's video, we're going to be solving some questions on binary operations. And with these questions, I hope you'll be able to apply in solving other problems on binary operations. So without wasting time, let's begin the class for today. The first question for today under binary operations that we are going to be solving says the operation is defined over the real numbers arrow by A operation B, okay, equal to A plus B plus half AB. Okay, now we are told to find one, two, operation 3, operation 4, okay, and number 2, okay, 8, operation 4, operation 7. Okay, now this is the first question that we will be solving today. We are given an operation and then we are told to evaluate this and this. Now, how do we go about this? Let's begin. Now, first of all, A operation B was given as this. So it means this is exactly what we are going to be using in evaluating these two questions that we are told to find. So let us begin. Now we have two operation 3 and operation 4. We have two operations. Now one is actually inside the bracket and the other is outside the bracket. So what do you do? First of all, you start solving with the operations inside the bracket, which is 2 operation 3. So if we should begin with that, it means bringing out our formula which was given to us, the operation A operation B equal to A plus B plus half AB. Now bring what we have in the bracket first, which is 2 operation 3. It simply means that A here is 2 and B here is 3. So it means anywhere I see A, I substitute 2, and anywhere I see B, I substitute the value of 3. So if we should do that, we're going to have something like this. 2 plus B now is 3 plus half, all right? Times A now is 2 and B is 3. I only substituted. Okay. So now without wasting time, let's proceed. Here becomes 2 operation 3 is equal to 2 plus 3 gives us 5 plus, all right. Now 1 times 2 gives us 2 and 2 times 3 gives us 6 and 6 divided by 2 gives us 3. So if we should add 3 to 5, we will get 8. What does that mean? It means what we have in the bracket now is 8. So now let us solve with the operation outside. What we're not going to be using now will be 8 operation 4 because everything in the bracket now is 8. So bringing it out, we have 8 operation 4. Now what does it mean? It means my new A is 8 and my new B is 4. So substituting again into the formula, we have A now becomes 8 plus B now becomes 4 plus half times A now is 8 times 4. Okay, it's as simple as that. So if we should do that, we're going to have this. 8 operation 4 becomes, now 8 plus, so yes, supposed to be 4, okay. Now 8 plus 4 now gives us 12 plus, now 1 times 8 gives us 8 and 8 times 4 gives us 32. And of course, 32 divided by 2 gives us 16. So here becomes 16. So if we should add 12 and 16 together, we will get 28. So it means the answer to question number 1 is 28. It is as simple as that. All right, it is as simple as that. So let's solve the next one, which is number 2. Now number 2 again, we are going to solve with one inside the bracket first, which is 4 operation 7. So we'll bring it out. 4 operation 7. Don't forget we are still using this one, the formula given here. So it means my A is 4 and my B is 7. So here becomes A now becomes 4 plus 7 plus half times 4 times 7. Alright, substitution. So automatically 4 operation 7 becomes 4 plus 7 now gives us 11, plus 1 times 4 gives us 4, and 4 times 7 gives us 28. Of course, 28 divided by 2 gives us 14. Alright, so if we should add up this, we're going to get 25. Okay, so what we have now in our bracket is 25. So working with the operation we have outside now, which is 8, it means we will now have 8 operation 25. Okay, so now my new A is 8 and my B now is 25. So working with that, A now becomes 8 plus 25 plus half times 8 times 25. Okay, so now let's proceed. 8 operation 25 becomes, now 8 plus 25 gives us 33, plus, now if 2 divide 8 we'll get 4. Alright, so 4 now times 25 will give us 100. So here becomes 100. Of course, if we add 133 together, we will get 133 as our answer. So you see, this is how you can actually solve problems that involves things like this. Alright, solve what is inside the bracket first. When you are done, then you have another operation outside before you go with the other operation, and then we will arrive at our final answer. Alright, so our question number 1 today answers include 28 and 133. So without wasting time, let us take a look at our next question for today. Okay, like I said, if this is the first time joining us, please help by subscribing, and then help also by sharing the video. Share the video so that other listeners, other mathematicians will also learn from it. All right. Okay, let's see. Okay, so let's take a look at question number 2. Question number 2. All right. Question number 2 says, okay, a binary operation is defined on the set arrow of real numbers by A operation B equal to A plus B, okay, A plus B minus 2AB. All right. Where A, B are elements of real numbers. Now we are told to calculate number 1, 5 minus 3 root 2 operation 6 minus 3 root 2. All right. And then we are told to give our answer in the form m plus n, okay, root 2. Now this is how we were told to leave our answer in this form. Our answer should be in sort form. So it means when we are done solving, our answer must have root 2, and then we're going to have rational numbers for m and n. Now, how do we go about solving this kind of question? Again, my A here represents 5 minus 3 root 2, and my B here represents 6 minus 3 root 2. So let us begin. So now A, now bringing the formula again to make it more easier or clearer, we're going to be having A operation B is equal to A plus B minus 2AB. So now let us substitute. Now A now is 5 minus 3 root 2 operation. B now is, our B now is 6 minus 3 root 2. So what does that mean? It means we'll have to substitute this now into the expression we have on the right hand side. So here now, A now is, here becomes 5 minus 3 root 2 plus, B now is 6 minus 3 root 2, okay, minus, now we have 2 here, and then we have A. A now is 5 minus 3 root 2. Alright, now we have B together, so it means we are times C, but no need to put the times because we already have brackets. So we're going to fix b now as 6 minus 3 root 2. Okay, now we have substituted. So what do we do? Let us begin calculating. Now here it comes. First of all, we have to open this bracket. And how do we open this bracket? The positive sign here multiply the signs inside the bracket. So here becomes 5 minus 3 root 2. Now plus times 6 still gives us plus 6. And plus times minus 3 root 2 still gives us minus 3 root 2. Nothing changes. Now minus 2. Now what we're going to do now is this. We are multiplying these two brackets. So first of all, 5 here multiplies everything in the second bracket, and then minus 3 root 2 also multiplies everything in the second bracket. So let's 5 do the multiplying first. Now let's go. 5 multiplied by 6 gives us 30, alright? Now 5 multiplied by minus 3 root 2 gives us minus 15 root 2. How is that possible? 5 times 3 gives us 15, that's all. They will bring our root 2. Now, 5 was multiplied. What we multiply now is minus 3 root 2. Now, if minus 3 root 2 multiplies 6, we will get minus 18 root 2. How did we get 18? 3 times 6 gives us 18. Alright. Now, when minus sign should come times minus sign, we will get the positive sign. Now, if 3 should multiply 3, we will get 9. And if root 2 should multiply root 2, we will get root 4. Alright. Because why 2 times 2 is 4. Now, let's proceed. Now, I can't minus 3 root 2, or I can subtract 3 root 2 from 5. But I can add 6 to 5, because 5 and 6, they are what? They are numbers without roots. So 5 plus 6 here will give us what? 11. So here becomes 11, okay? Now, I have minus 3 root 2. I have minus 3 root 2. Both of them have same roots. So because both numbers have same roots, I can simply say minus 3 minus 3. And minus 3 minus 3 gives us minus 6. So our answer becomes minus 6 root 2. Alright. Now, minus, let's go here now. 2 into the brackets of, now, we have 30. Okay. Now, I have root 2 here. I have root 2 here, both. So it means I can simply say minus 15 minus 18. If, for instance, here was root 3 and here is root 2, I can't work with them because the roots are different. So minus 15 minus 18 now will give us minus, okay, 15 gives us 30. All right, then we have 3. So we have minus 33. So here becomes minus 33 root 2. Alright, so you just bring your root 2 because they have root 2 in common. Now plus, now here becomes 18. Now the question is, how did I get 18? It's very simple. Now the square root of 4 is 2. Then 2 multiplied by this 9 gives us 18. It's as simple as that. Square root of 4 is 2. 2 times 9 gives us 18. Now let's proceed. Here becomes, okay, I want to take it step by step. Here becomes 11 minus 6 root 2, okay. Minus, now here becomes 2 into the bracket of, now 30 plus 18 can be added because they are just numbers. Now 30 plus 18 gives us 48 minus 33 root 2. Okay, step by step. Now next, now we have, okay, 11 minus 6 root 2. Now 2 will open the bracket. 2 open the bracket. Now we have minus here. Now 2 times 48 gives us 96. Okay. Now minus times this minus here will give us a positive sign. Alright. So now 2 times 33 root 2 gives us 66 root 2. How did I get 66? 2 times 33 gives us 66. 2 cannot multiply this 2 because why? This other 2 is inside a root, so it can't multiply. So now what do we do next now? Here we have root 2, here we have root 2. Here we have ordinary 11, and here we have just a ordinary number which is minus 96. So it means 11 and minus 96 works together, and minus 6 root 2 and 66 root 2 works together because both of them has what? Roots. Now 66 root 2 minus 6 root 2 will give us what? 60 root 2. Because if you take away 6 away from 66, we will get 60 left. Now, here we have 11 minus 96. Now, 11 minus 96 will give us minus 85. Now, why are we having a negative sign here? It's because 96 is bigger than what? 11. So the answer becomes negative. So from this perspective now, our n here, all right, is 60. N is 60, all right? And if we were to find the values of n, and then our m here is minus 85. Okay, minus 85. So this is the answer to this question, leaving our answer in short form. You will notice that in the final answer, I also have root 2 present, because that is how we were told to represent this information. Okay, so I hope that helps. Now, this is not just a question alone. So this is not just a question alone to this question. We have other questions. So the next question that we were told to find now is apart from this. Let's see. Still under question number 2. Still under question number 2. Okay. Call me. Okay. Now, still under question 2. Still under question 2, we were told to find the identity element. We were told to find the identity element of this operation. Now, how do you solve for identity element? This is what we're going to do. First step, replace your B, all right, with your identity. This is the symbol for identity, okay? Replace your B with your identity, okay, and equate it to your A. When you are solving for identities, we are going to get two equations, equation 1 and equation 2. All right. Now, equation 1 is gotten by substituting the second, alphabet here with your identity. So, for instance, if I have x operation y, and I want to get equation 1, it becomes x operation identity. Y becomes identity equal. So, what do I have here? Equal to x. Again, if I have m operation a, it becomes m operation identity equal to what? To n. Alright, so it's as simple as that. So without wasting time, let us see what we can do here. So now, to get equation 1, replace b with your identity. So we're going to be having a operation identity is equal to a. Call it what? Equation 1. Now that we've gotten equation 1, how do you get equation 2? You will use the right hand side of the equation. So you use the left hand side of the equation to get equation 1, and then you use the right hand side of the equation to get equation 2. Now, how do you get equation 2? Don't forget that we have substituted b now. We have substituted identity for b. So it means on the right hand side, anywhere we have b, we will now substitute what's now identity. So bringing this equation in the right hand side here, which is a plus b minus 2ab. If we are writing this now, it becomes a plus b now is identity minus 2a identity, because we also have b here. So now what do you call this now? You call this what now? Equation what? 2. Equation 1 is a and equation 2 is a plus identity minus 2a identity. Now, when we have gotten equation 1 and equation 2, what we are going to do now is this. Equate equation 1 and equation 2. Now, equation 1 is a is equal to equation 2 is a plus identity minus 2a identity. Equate the both of them. Equate the both of them. Now, if we should equate the both of them, this is what we are going to do. You will notice that in this question, we have two identities. One is here, and the other one is which was 2a. So what do? Because we are told to look for identity, we must make sure that we have one identity, not two identity. And the question is, how can we make two identities become one? It's by factorization, right? Because when you factorize what they have in common, two identity becomes one. So if we should do this, first of all, a that does not carry an identity or has to go to the left hand side to meet a. So if a crosses the equality sign, it becomes minus a. So here becomes a minus a is equal to, what do we have left here now? identity minus 2a identity. Now, you see, we only have the identity on the right hand side and the non-identity on the left hand side. So now, a minus a actually is 0. Now, you ask yourself a question. What does these two guys here have in common? They have identity in common because there's an identity here and there's another identity here. So what do? Bring out the identity that they have in common. Open a bracket. If identity should cancel out identity, what do we have left here? 1. So here becomes 1 minus. And if identity here should cancel identity here, what do we have left here now? 2a. All right. So you see, from two identities, it has become one identity. Why? Because we were able to factorize. All right. So now we are looking for identity. What does that mean? It means identity has to be the subject of the formula. It has to stand alone. So for identity to stand alone here, I have to divide both sides by 1 minus 2a. All right. Now, if 1 minus 2a cancels 1 minus 2a, what do we have left, class? We have identity left. Class 0 divided by 1 minus 2a gives us 0. So it means in this question, our identity element is actually 0. Okay, now this is actually the second question that was given to us under number 2 question. So, apart from this, we also have a third question, which has to do with the inverse. With the inverse of this same operation. With the inverse of this same operation. Now, the question is, how do we find the inverse of this operation? Now, this is what we are about to get. The inverse. Now, let's see. Okay, let's see if we can solve it this way. Now, according to the question, right? According to the question, it says find the inverse of the general element. Find the inverse of the general element A, element of arrow. Okay? Okay, blah, blah, blah. So now, we will also to find the inverse now. How do we solve for the inverse? This is what we do. This is what we're going to do. Bring about the operation which says A operation B equal to A plus B minus 2AB. Now, let's see for the inverse of A. Now, what we're going to do is this now. Again, we are also going to get equation 1 and we are also going to get equation 2. All right. But one thing you should understand about inverse of binary operations, your equation 1 is always equal to your identity. All right. Your equation 1 is always equal to your identity. And how do you do that? You see now, this B here, we're going to replace it with the inverse of A. But in identity, we replace B with identity. But here in the inverse, we're going to replace B with the inverse of A. Or you replace A with the inverse of B. Now, what is the inverse of A? Inverse of A is written as A raised to the power of minus 1. So if we do that, here becomes A operation A inverse, which is the inverse of A, is equal to identity. It is always equal to what? Identity. So here becomes equation number 1. Alright, equation number 1. So now let's proceed. Now that we have gotten equation 1 with the left hand side of the equation, what do we do to get equation 2 now? We will use the right hand side of the equation. So let's bring down the right hand side of the equation, which says A plus B minus 2AB. Now don't forget that we have substituted A inverse for B. So wherever we have A inverse, what do we do now? Sorry, whenever we have B here, when we are writing this again on the right hand side, we are going to substitute what? A inverse. So here becomes A plus B now is A inverse minus 2A. B now is A inverse. Now you call this what? Equation 2. Equation 2. Now that we've got equation 1 and equation 2, what do? We equate them together. Now equation 1 is identity. And equation 2 is A plus A inverse minus 2A inverse. Right? Minus 2A inverse. You also notice that here we have two inverses. In some cases, it will be 1. You understand? Why here now we have A inverse here and we also have A inverse here. In some cases again, the values of identities are given. For example, they will tell you find the inverse of 5 if the identity element is 4. So if you are looking for the inverse of 5 if the identity element is 4, it means whenever you have identity element you give 4, and whenever you have your inverse you give 5. But here we were not given any values, so our identity remains our identity, and our inverse remains our inverse. But what we are going to do here now is this. We will make sure that the 2 inverse becomes 1. And how did I say we do that? By factorizing. So first of all, a here goes to the left hand side of the equation because a is having no inverse. So here becomes identity minus a, because when a crosses the equality becomes a negative sign, is equal to a inverse minus 2aa inverse. Alright. So here becomes identity minus a is equal to. Now, we have 2 inverses here. They have inverse in common. So bring what they have in common, which is the inverse. So here becomes a inverse. Then we open a bracket because they have nothing else in common. Now, if a inverse should cancel out a inverse, what do we have? 1. Just the way when identity cancels out identity, what do we have? 1. Now, minus, if a inverse should cancel a inverse, what do we have left here? 2a. Now we have just 1 inverse. So what do? Divide both sides by 1 minus 2a so that the inverse becomes the subject of the formula. Now when 1 minus 2a cancels out 1 minus 2a, we are having a inverse as identity minus a all over 1 minus 2a. That becomes the inverse of a. Alright, so you see, this is how you can actually solve problems on inverse of binary operations. So this brings us to the end of question number 2. And without wasting time, let us solve other questions, which has to do with question number 3. Like I said, if this is your first time joining us, you are welcome to our channel. Here we help students understand mathematics in a better way. And what you just have to do for us is to see that you help us share our videos, leave your comments in the comment section, and also do not forget to subscribe, right? Do not forget. That is the only way you can help us, all right? So that other students will also have the opportunity to learn from what you are learning now. All right, let's go to question number 3. Question number 3, okay. Question number 3 says, a binary operation is defined on a set arrow of real numbers by A operation B equal to AB over 4. All right. Now find the value of root 6. Find root 2 operation root 6. All right. This is the question. We are told to find the value of root 2 operation root 6. Again, here, A is root 2, B is root 6. So let's substitute. Solution. Bring it down root 2 operation root 6. This is what we're going to get. Now, A means root 2, B means root 6. So anywhere I have A here, I'll give root 2. Multiplied by anywhere I have B here, I'll give root 6 all over 4. All right. Now, let's proceed. Root 2 multiplied by root 6 will give us root 8 over 4. But this is not a simplified answer. Because you know why? Root 8 can further be simplified. And how do you do that? You think of two numbers that when you multiply, one has a perfect square and the other does not. So those two numbers here are 4 and 2. But I can give you a way that you can actually solve it on your own. For instance, you look for the LCM of 8. That is how you do it. Now, how do you do it now? Now, 2 into 8 gives us 4. 2 into 4 gives us 2. And 2 into 2 gives us 1. So what you're going to do now is this. Now, circle out 2 numbers that are the same. Now, there are 3 numbers that are the same there, but circle out just 2. So now that we have circled out the first 2, we just have 1 number left. So what do? Multiply the ones that you have circled. 2 times 2 gives you 4. So the other number is 2. That is exactly how we got 4 and 2. So for instance, let's take a look at 80. Root 80. We want to simplify root 80. How do you go about it? Again, you use the LCM method. LCM method for 80. 2 can go into 80 40 times. 2 can go into 40, 20, into 20, 10, into 10, 5, and into 5, 1. So what did I say you do next? Circle out 2 numbers that are the same. So we have 2 here, and we also have 2 again that are the same. Now we just have 1 number left, 5. So what do? All the numbers that you have circled, multiply all of them. Now 2 times 2 gives you 4, 4 times 2 gives you 8, and 8 times 2 gives you 16. So the two numbers you would be using is 16 times 5. It's as simple as that. Alright, so you can do others on your own using the LCM method. Alright, now let's go back to the class. So automatically here becomes root 8 now becomes 4 times 2 all over 4. Alright, so now what do we do next? Here becomes the square root of 4 is 2. What do we have left here now? Root 2. You get it? How did I get this 2 outside? The square root of this 4. But if you use the square root of 2, you'll get the decimals. But we don't want decimals. So we have to leave it as what? Root 2. Now, all over, what do we have in the denominator? 4. Now, these 2 here can actually cancel out 4. So if 2 cancel out 4, what do we have left here? 2. So our final answer becomes root 2 over 2. That becomes the answer to that question. Alright. So now you see, there are different ways you solve problems. And one thing you should understand about mathematics is that they are all related. From indices, you can go into logarithm. From logarithm, you can go into solve. From solve, you can go. They are just like that. So what you have to do is to see that you have at least ideas in these different topics. So that when, for instance, you are solving from solve and then finally you jump into quadratic equation, you won't be lost. You still have something to, to write down. Knowledge is power. All right. So now, without wasting time, let's go to our next question. Let's go to our next what? Question. Okay. Let's see. All right. The question says, a binary operation on a set of rational numbers is defined by A operation B equal to B squared minus A squared over 2AB. All right, first stop. Find, okay, 3 operation 2. 3 operation 2. Again, here A is 3 and B is 2. So what do? Substitute. It's as simple as that. Let's substitute. Now if we should substitute solution, it becomes A now is 3, operation 2 becomes B now, where we have B, we give 2, and where we have A, we give 3. Alright, so here becomes 2 raised to the power of 2 minus 3 raised to the power of 2 all over, here becomes 2 brackets, A is 3 and B is 2. It's as simple as that. Alright, so now here becomes, according to the laws of indices, 2 raised to the power 2 means 2 times 2, which is 4, minus 3 raised to the power 2 means 3 times 3, which is 9, over 2 times 3 gives us 6, and 6 times 2 gives us 12. So class, 4 minus 9 gives us minus 5 over 12. So that gives us the answer to that question, minus 5 over 12. You see how simple it is? It's just for you to understand what your A means, what your B means, and then yes, you are good to go. You are good to go. All right, let's proceed and see what we have. Let's see what our next question brings. Okay. All right, let's see. Okay, this is not so clear. Not so clear. Okay, now the question says, a binary operation defined on a set of real numbers A operation B equal to A over B, all right, plus B over A, all right, where A and B belong to, okay, where I can't see that clearly, but simplify, look at what we're supposed to simplify. Simplify x plus 1, all right, operation 2 equals to 3. This is what we were told to simplify. X operation 1, or sorry, x plus 1 operation 2 equal to 3. Let's see. Now, A here is x plus 1, B here is 2. But don't forget that these two operations equal to what? 3. So let's see what we're going to do. So now, bringing these two operations, it becomes x plus 1 operation 2 is equal to, watch, a now is x plus 1 and b is 2. So whenever I have a, I give x plus 1, and whenever I have b, I give 2. So here it becomes x plus 1 over b now is 2 plus, right, 2 over x plus 1 equal to what? To 3. Because it said both are equal to what? 3. Now, what can we do? Without wasting time, let's base 3 over 1, and then let's look for the LCM of the denominators. The LCM of the denominators are 2, x plus 1, and 1. So our LCM now here includes 2 into the brackets of x plus 1. Because if you want to look for the LCM now, let's see here. LCM of 2 and x plus 1. Now what can go here now? 2 can go. 2 into 2 is 1, but 2 cannot go into x plus 1. So we still have x plus 1. So what can go now? X plus 1. So 1, 1. So the LCM becomes 2 and x plus 1. This is what we're doing here. Now let's proceed. What do we do now? The denominator here is 2. If 2 should cancel out 2, what am I going to get left? I'm going to get x plus 1 left. So x plus 1 now will multiply the numerator, which is x plus 1. So here becomes x plus 1 times another x plus 1. How did I do this? Come again. When 2 divides 2, we have x plus 1 left. X plus 1 multiply x plus 1. What did I do here? Plus. Now the denominator here is x plus 1. If x plus 1 should cancel x plus 1, what am I going to have left? 2. So what will the 2 do now? 2 multiply the 2 on top, which is 2 bracket 2. Okay? Equal to. Now, 1 into 2s plus 1, we still give us 2 into the bracket of s plus 1. Then 2 into the bracket of s plus 1 will multiply 3 on top. So here becomes 2 into the bracket of x plus 1, bracket 3. Aha. That's as simple as this. So let's work it out. Let's see what we can do. Now, x multiplies everything in the second bracket, and 1 multiplies everything in the second bracket. So let's see. X multiplied by x gives us x squared plus x multiplied by 1 gives us x. So now x has multiplied the second bracket. So what is multiplying now? 1 plus 1 multiplied by everything here will still give us x plus 1. Nothing changes. Plus 2 multiplied by 2 gives us 4, right? Equal to 2 times x gives us 2 times x gives us 2x plus 2. Okay, so let's just do it this way. 2 times x gives us 2x. 2x times 3 gives us 6x. Plus 2 times 1 gives us 1. Sorry, 2 times 1 gives us 2. 2 times 3 again gives us what? 6. So we have 6x plus 6. Now, you will notice that here there's a square here. So it means we can as well say that this question leads us to a quadratic equation. So now let us try to rewrite this equation to see that all are equated to 0. Okay, so what are we going to do now? So we have x squared. Okay, now x plus x gives us 2x plus 2x. Now plus 1 plus 4 gives us 5 equal to 6x plus 6. Now everything on the right hand side, let's take it to the left hand side and then equate the equation to 0. So we're going to have this now, x squared plus 2x. If 6x crosses, it becomes what? Minus 6x. Alright, now plus 5. If plus 6 crosses, it becomes what? Minus 6. All equal to what? 0. So what we just did now is to see how we can, reduce this into a quadratic form, and then we start solving using methods of quadratic equations. Now here becomes x squared. Alright, now 2x minus 6x gives us minus 4x. Alright, now 5 minus 6 gives us minus 1, all equal to 0. Because of the space of the board, let's see how we can minimize. Okay, now x squared minus 4x minus 1 equal to 0. How do we solve this? Now we can choose to apply the formula method, We can choose to apply the factorization method. We can also choose to apply the completing the square method. And that's what you know. So here in this case, let us apply the formula method. All right. Now the formula method here, in this case, my a here is equal to 1. All right. My b now is equal to minus 4, and my c is equal to minus 1. All right. Using the formula method. And what is the formula? The formula is x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Alright, all over 2a. So let's see what we can do here. Now, without wasting time, let us see what we can do. B now is minus 4, a is 1, and c is minus 1. So let's see. Sorry, a is 1 and c is minus 1. Yes. So let's see. Let's substitute now. Here becomes x is equal to minus. Now my b now is minus 4. Okay, substituting. Plus or minus the square root of b again is minus 4. So here becomes minus 4 raised to the power 2 because of the square. Minus 4 into the bracket of a is 1. And c is minus 1. All over 2 bracket 1. So you see, I've substituted these values into the formula. So that's what we're going to get now. Here becomes x is equal to, now minus times minus 4 gives us a positive 4 plus or minus square root of, minus 4 raised to the power 2 is minus 4 times minus 4, which is a positive 16. Alright. Now I have minus times minus. Now minus times minus here gives us what? Plus. Now 4 times 1 gives us 4. 4 times 1 gives us 4. So we have 16 plus 4 all over 2 times 1 gives us 2. Right. Now without wasting time, what's it called? 16 plus 4 is what? 20. So automatically we have this. X is equal to 4 plus or minus square root of 20 all over 2. But don't forget that these 2, alright, let's see, these 2 can actually cancel 4. But these 2 cannot cancel root 20. So we can't use the 2 to cancel 4. Alright, it is wrong. So now, what we are going to do now is this. Alright, so here becomes, okay, here becomes, if we have something like 2 plus minus 4, it simply means 2 plus 4 or 2 minus 4 when you expand. So in this case here now, if we should expand what we have now, we will be getting x is equal to, alright, 4 plus root 20 over 2 or 4 minus root 20 over 2 because we have plus or minus sign. And of course, root 20, when you simplify root 20, okay, using the LCM pattern that I taught you, all right, we will be getting 2 root 5. How is that possible? Let's use the LCM. LCM of 20. Now, 2 into 20 gives us 10, 2 into 10 gives us 5, and 5 into 5 gives us 1. So now, two numbers that are the same, we have 2. So 2 times 2 gives us what? 4. So the two numbers I'm using becomes 4 times 5. Alright. Now the square root of 4 is 2. So what will be inside the roots now? 5. So what do we have? 2 root 5. Well, we simplify root 20. So here becomes x is equal to 4 plus 2 root 5 over 2. Or 4 minus 2 root 5 over 2. Now, 2 can divide 4. 2 can also divide 2. So now we can use it. So x becomes, if 2 should cancel out 4, we will have 2 plus. If 2 should cancel out 2, what do we have left here now? Root 5. Or, okay. And then, if 2 should cancel out 2 here, 4 here, I'll have 2 minus, if 2 should cancel out 2, what do I have left now? Root 5. So you see, these are the values for x. X is either 2 plus root 5 or 2 minus root 5. if we should solve using the formula method. Okay, so you see, these are the methods you can simply apply when you are solving a question that looks like that. All right, so now without wasting time, let's see what our next question brings. Don't forget, the topic we are still working on is binary operations. Binary operations. All right, binary operations. Okay, let us see the next question that we have. The next question that we have. Okay, let's see. Okay, doesn't seem clear. Let's see. Coming. Okay, x plus y. Okay, two binary operations. Let's see. Two binary operations. So here we're given two operations. We have this, and then we have this. Alright, two binary operations are defined on a set of real numbers R such that x operation y equal to x squared plus y, and alright, x of which is the second operation now is equal to x plus y. Alright, comma. Now x, y are elements of arrow. Now the question now says if x operation y is equal to x operation y, comma, what is the possible values of x? What is the possible values of x? What is the possible values of x? Class, let us take a look at this question and see what we can do here. First of all, we're given two operations, 1 and 2. Now watch. The first operation says x operation y is x squared plus y. And the second operation says x operation y again is now x plus y. But we were now told that if this operation is equal to this operation, what does that mean? If x squared plus y is equal to x plus y, simple as that. So let's go. Solution. X squared plus y is equal to x plus y. That's what it means. Now we are asked to find the possible values of x. Simple. Let's see what we're going to do here. In this case, let us equate this mass to 0. Let's equate the equation to 0 by taking everything on the right hand side to the what? To the left hand side of the equation. So it means we're going to get something like this now. X squared. If x crosses, it becomes minus x. Now we have plus y here. If plus y crosses, it becomes minus y. Now equates it to what? To 0. Now here we're going to get x squared minus x is equal to 0. How? Because y minus y is 0. So there's no y again in the question. Now, x squared minus x has x in common. So what do? Bring out the x that you have in common. If x should cancel x squared, I will get x here. Because according to x squared means x times x. So if you remove one of the x, we have this x left, which is this. Minus, if x should cancel x, we get 1 equal to 0. Class, what does it mean? It simply means that x here is equal to this 0, or x minus 1 inside the bracket is equal to 0. Class, here, if s is equal to 0, or if minus 1 crosses the equality sign becomes plus 1, x is equal to 1. Therefore, the values for x becomes 0 and what? 1. These are the possible values of x, 0 and 1. 0 and 1. So this is how you can actually solve a question that looks like this. Follow how it looks. Understand the question and then get solving. Alright, get solving. So that is our question. Let us see what the next question have for us. Okay. Still on binary operations. Don't forget, always help us share our videos so other students can learn from it. So that other students can learn from it. Okay, let's see what we have here. Okay, a binary operation is defined by A operation B equal to A squared minus B squared plus AB, where A and B are real numbers. Now this is what the said we should evaluate. Evaluate root 3 operation root 2. That is the question. Evaluate root 3 operation root 2. Now A is root 3, B is root 2. Solution. Let's bring that, okay? Now, anywhere we have A, we will give root 3. Operation root 2 becomes, A now here becomes root 3. But don't forget A carries a square, so the square base, okay, raised to the power of 2 minus, now B now is root 2, raised to the power of 2, plus A now is root 3, B now is root 2. Simple substitution. Simple substitution. Now, square cancel out square roots. What do I have? 3. Minus. Square cancel out square roots. What do I have? 2. Plus. Root 3 multiplied by root 2 gives us what? Root 6. Class, what is 3 minus 2? 3 minus 2 becomes 1 minus root 6. Leaving our answer in sort form. This is what we are going to get. Because why? We can't simplify root 6. Why? Look up. If we try to use the LCM, 3 into 6 is 3, 3 into 3 is 1. You will notice that there are no two numbers that are the same. So root 6 remains root 6. You can simplify it. Apart from root 6, there are also other numbers that can be simplified. For example, root 5, right, root 3, root 11. These are numbers that cannot be simplified because when you look for their LCMs, there are no two numbers that are actually the same. Good. So this is the answer to the question, leaving our answer in solved form. Alright. Let's go to the next question for today. Okay. The next question says, all right, this is a tabular. This is actually a tabular. Okay. Let's see. Let's see. Oh, this is not clear at all. Okay, let's go to the next question. So we're given a table. K, L, M, and N. K, L, M, and N. Then we were given L, N, K, M. Here we have M, N, L, K. Here we have K, L, M, N. And here we have L, K, M, N. Alright. Now, in this question, we were told to find the identity elements. We were told to find the identity elements. Now, we don't need to solve, I'll just give you the answer. First of all, we have, on our row, we have KLMN, and on our column, we have KLMN. This is what we just do. I will go to any of these letters that has KLMN inside on the column and also KLMN, on the row. Let's go. This is K. Under K, I have LMKL. Alright? Let's help me. LMKL, okay? Which does not correspond with KLMN. So that one is away. Now under L, I have NNLK, which does not also correspond with the column here. And under M, I have KLMN, which corresponds here. Now let's come here now and check. Under M also here, I also have KLMN, which correspond with what we have on our row. So our answer becomes what? N. Our identity element is N. It's as simple as that. Alright, our identity element is N. Because under N, our, what we have here corresponds with the column here, and under N, what we have here corresponds with the row here. So the answer automatically becomes N. So class, this is how we come to the end of today's class, mainly on binary operations. I hope you've learned something new. So this is the first time joining us, please don't forget to subscribe and also make sure your notification bell is on. Alright, put it on so that whenever we give new videos, you'll be among the first students to be notified, and also help us share our videos. So we'll meet again in our next class. Keep on watching Jeff Nano Mathematics class, and bye for now.